Solve for all real numbers. 2 sine x cos x plus the square root of 2 cos x equals 0. Let's do first. Let's factor out a cosine x. There's a cosine x in both of them. So when we do that, we're left with cosine x. When we rip a cosine x from 2 sine x cos x, that leaves us with 2 sine x. And then when we rip a cos x from that, that leaves us with root 2. Set it equal to 0, bada bing. Now what we do is we use the zero product property. We say cosine x equals 0. And then we also say 2 sine x plus root 2 equals 0 as well. Solve each one of these individually. This guy we can solve right away. All we do is inverse cosine both sides. Now when we inverse cosine 0, what we're asking ourselves is what angle would it take in order for us to get an x value of 0 on the unit circle? Remember, cosine is the x value. So if I'm looking at the unit circle like that, okay, the x value is 0 at 2 spots. Right there at the tippy top at 0, 1, and right there at the very bottom at 0, -1. So that would mean that x is going to equal the angle measures pi over 2 and 3 pi over 2. So x is going to equal pi over 2 and 3 pi over 2. Now, this is just for everything in between 0 and 2 pi. So in reality, what we have is x is going to equal pi over 2. And if I spin around it again and spin around it again and spin around it again and spin around it again. So every time we go around 2 pi, we have another 0. So what we'll do is if we were to add 2 pi or add 4 pi or subtract 2 pi or subtract 4 pi or subtract 10 pi or subtract any even number pi, what we're going to do is we're going to say that that's going to be 2k pi, where k is any integer. Okay, now that happens at pi over 2, and that also happens at 3 pi over 2. So 3 pi over 2 plus 2k pi, where k could be 1, 10, -1,000, as long as it's any integer k. By the way, that's just 1/2. That was the easy part. Now I have to do this ugly part over here. No matter, I'm going to subtract root 2, like that, minus root 2, cross you out. That gets me 2 sine x equals negative the square root of 2. Let's divide everything by 2. And that gets me sine x equals negative root 2 over 2. How do I get x all by itself? Well, you inverse sine, of course. Inverse sine, cross you out. This is asking us what angle measurements give us a y value, because sine is y, a y value of negative root 2 over 2. Well, let's draw ourselves a unit circle. Okay, y values are negative down here in quadrant 3 and quadrant 4. Negative root 2 over 2 is right in the middle here of the 3 dots that we would normally draw out. That angle right here in the middle is 5 pi over 4. And that angle is going to be 7 pi over 4. So in the same way, we have 2 more x values, 5 pi over 4, 7 pi over 4. And x is going to equal 5 pi over 4 plus 2k pi. And x equals 7 pi over 4 plus 2k pi. Now I have a feeling that something's going to happen here in the multiple choice, and I see it. Because when I'm looking up here, I have 1, 2, 3 options when I came up with 4, right? So what they're doing up here is, first off, if we look at the green, we see 5 pi over 4, 7 pi over 4. C is going to be our guy. But why is only one of them provided here when we came up with 2? Well, pi over 2 plus 2k pi, I mean, think about it. this repeats every pi. So what they're doing in our options is they're just converting this into one problem. So they'll just say pi over 2, and instead of saying add 2k pi to that and add 2k pi to that, just take that and add 1 pi every single time. Because when you add a pi to pi over 2, you get 3 pi over 2. And when you add it again, you get 5 pi over 2, which is basically me just repeating that. So they're rewriting this as plus regular k pi. So kind of strange how this one ended up. But, you know, it worked. Worked just fine. Still strange.